By the end of the video, you should be able to make a full body FPS controller like this. So I've already created an empty new Unity project named Unity Tutorial. I've already imported Pro Builder and then made a simple starting scene here so that we can walk around. And at the meantime, I also create a separate Unity project named Testing Project. Basically, it will be the project where we're going to import every third-party assets and stuff like that and test everything out. So first of all, we have to get our player model, import the starter asset, import everything. After you have imported the starter asset, head to this folder. All we need is this prefab. So we'll click Export Package, uncheck anything that's irrelevant. So in this case, we only want the model. So we're going to uncheck Editor, Input System, Mobile, and then I think these are all good. We still need a prefab. Click Export, and then export it directly to our directory. So click Import to import everything, and that's it. For the sake of project management, I'm gonna create a folder called Resources, and then basically put everything inside it. And then we're all set. Now, instantiate the character controller. We have our model now, and now we're gonna download all of the animations. So personally, I prefer to use this website, Mixamo.com. If you haven't used it before, it's a great website for all of the motion captured 3D animation stuff. First of all, we need the idle animation. Download. So make sure you have FPX for Unity and without skin checked. Right, so that's the idle animation. Then we're just gonna proceed to download every other animation in different direction. Walk forward, walk leftward, rightward, and backward. When you're downloading the animation, make sure you just check the In Place button, because we're gonna control everything for this model. Finally, we need an extra T-pose animation. Alright, when that's done, we simply need to import all of the animations we just downloaded. Now, for starters, we need to identify the T-pose animation and rig that first. Humanoid, create from this model, standard. So after configuring the T-pose animation, we simply need to select every other animations and rig them based on the T-pose animation. And then for the animations, we actually want every one of them to be looping and then apply a root transform position, rotation and stuff like that. And then we're also going to rename them. Alright, let's proceed to add our Animator Controller. Right click, create an Animator Controller. We're going to name it Player Controller. Go into the Animator Controller. First of all, we're going to create a default state. We're going to create from new blend tree, and we're going to name the blend tree base state. Go into the blend tree. For the blend type, we're going to use 2D freeform directional, as this blend type allows us to stack multiple animations onto a single direction. Before we start doing anything, we need to add two float parameters. One is called X velocity. Another one Y velocity. And then for the blend tree parameters, we're going to use X velocity and Y velocity. Since we have 9 different animations, we're going to add 9 different motion fields. And then start filling our animation. Alright, we're going to fill in our position X and position Y. For position X, it means X velocity, and for position Y, it means Y velocity. For our first motion field, idling, when the player's idling, it's not moving, so both the X velocity and Y velocity should remain 0. For walking, we want the player to walk forward at a speed of 2 meters per second, so for Y velocity, we're going to fill in 2. When the player's walking left, we want the player to have -2 in terms of X velocity. And when the player's walking right, we want the player to have 2 in the X velocity, and 0 in the Y velocity. When the player's walking back, we want the player to have 0 X velocity and -2 Y velocity. For the running animation, the player's gonna have 0 X velocity and 6 in terms of Y velocity. You can really input anything you want. I'm just input 6 for the sake of this tutorial. When the player is running left, it should have -6 in terms of X velocity and 0 in terms of Y velocity. And then apply the same logic to right strafe. 6 in X velocity and 0 in Y velocity. And finally, when a player is running back, the player should have -6 in Y velocity. Alright, that's it. Now, using different X velocity and Y velocity, our player should have different animations, and the blend tree should also allow the animator to interpolate animation smoothly between each velocity. And that's it for Animator Controller. Now back to our scene view. The first thing we have to do is to unpack our prefab by going to prefab and unpack completely. And now for the Animator Controller part, we'll just simply drag in the controller we just created. Click apply root motion, and we're done. Secondly, remove character controller. We don't use character controller and use RigidBody Controller instead because RigidBody Controller allows the player to be affected by different forces. Now, search RigidBody. And then also search Capsule Collider. We use the Capsule Collider to stand on the ground and for other collision detection purposes. For the RigidBody, use a valid and logical mass. In this case, I use 54. And then for the constraints, freeze every rotations. And also check interpolation. And zeros out of the drags and angular drags. And for the Capsule Collider, we're going to set a center to 0.89. Radius to 0.28. And then finally height to 1.79. And that's it. The next step is to import a new input system. Head to Edit, Project Setting, Player, and then Other Settings. In the bottom, you can find this. Change the input setting to New Input System. Apply. This may take a second to reload. When that's done, go to Window and Package Manager. Search for Input System. Install. After the package is done compiling, we can go create a new InputAction map by right-click, Create, and InputAction. For this time, we're going to name it Player Controls. To create different keyboard bindings, we have to create action map first. I'm gonna name it player. An action map can have different actions, and for the first action, I'm gonna name it move, as it will be controlling the basic movement of our player. The action type will be value, and control type will be vector 2. Let's hit the plus sign and then add a 2D vector composite, and delete the default one. As you can see, there are 4 options here. For up, we'll bind the path to the key W. For down, we'll bind the path to S. Left to A. And right to D. Next, we're gonna create an action for our mouse. So, it will be called look. The action type is still the same. It will be value. And still vector 2, as it will be moving in a 2D plane. For the binding, we go to mouse and delta. And finally, for this tutorial, I'm gonna create another action called run, as it will decide whether the player should run. The action type should remain button, and the binding should bind to left shift. Back to our player, we need to add a new component called player input to handle our input stuff. You can also actually add another input manager, but we won't touch into that at this point. Alright, so input action, deformat player, and behavior will be invoke C# event, because like compared to send messages or invoke Unity events, C# events are basically faster and generates less garbage. Right, so that's all set. Oh, by the way, back to our input action. You may be wondering why I didn't check this box like other tutorials do. That's because in the future tutorials, I'm gonna make a system that allows the player to basically customize their keyboard bindings. And to do that, we cannot actually, check this box. Now we basically have everything set, and we can move on to the scripting part. So create folder, I'm just gonna name the script. Then I'm just gonna go to create 2 C# scripts. One is named Player Controller, and another one named Input Manager. Alright, let's attach them onto our player. Before we start any of these things, it will be a good habit for us to start a namespace. Then do the same for Input Manager. For our Input Manager, we need 2 more namespaces, Unity Engine.InputSystem and Unity Engine.InputSystem.Interactions. After adding all of the essential namespaces, now we need a reference to our player input component we just created. To do that, we'll use a serialized field and then private player input, and we'll name it player input. And secondly, we'll create several essential read-only variables that will inform the player controller the status of our input actions. We'll create a read-only feature by creating a public getter and private setter. And repeat this to look and run. Lastly, we need to have access to our current input action map and our individual input actions. We'll also create variables like this. Done. The next step is to actually obtain our current input action map and then hook up our individual input actions with them. To do that, we need an awake function, and then we'll find our current input action map by getting that from our player input component. And subsequently, we'll get our individual input actions from our input action map. Alright, right now we'll subscribe every callback functions to our input actions. We start by doing this. Alright, let's start creating every callback functions we just created. Each callback function has their own callback parameters, starting with InputAction.callbackContext. Within each callback function, we'll obtain the essential information from the passing context parameter. Alright, that's done. We also need a statement when we stop performing all of the actions. We can achieve that by calling the same callback function with cancelled. The difference between performed and cancelled is that performed is when the key binding started, and cancelled is when a key binding has finished. And then finally, we can organize our project a little bit by disabling and enabling our current input action map when we're enabling this input manager. Alright, that's everything for the input manager. The next step is to set up the basics for our player controller. We'll start by creating all of the components and all of the essential variables. And we also have to have access to our input manager. Finally, we'll create several essential variables for us to access our animation stuff. And then don't forget the properties we set in our animator, X velocity and Y velocity. Since we need to have access to them, we need to have their hash numbers. Then in our start method, we'll start initializing all of our components and variables. Lastly, we have to get our hash numbers from our animator. Again, when you are putting in the string value, make sure you have exactly the same word by word. For the next step, we're going to move our player around. First thing first, we're going to define our player movement speed. As pre-mentioned before, our walking speed should be 2 meters per second, while our running speed should be 6 meters per second. Now, we're going to define the move method, which should be running in the fixed update function. First of all, we're going to check if the player has a component animator. Otherwise, the move function will not run. Then, we're going to define our target speed, which is the speed that we desire the player to be running at. If you haven't heard of this expression, it basically means that if the player has pressed the run button, our target speed will be running speed. Otherwise, it will be walk speed. Now, if the player hasn't pressed anything at all, the target speed should be The next step, we're going to define a current velocity variable, which is the 2D representation of our velocity. And now, we're going to set our current speed to our target speed. Finally, we'll set the velocity of our rigid body to our current velocity. However, setting velocities directly to our rigid body will make our rigid body indifferent to other forces. Hence, we're going to apply a force onto our rigid body. Since we're still calculating in local mode, we're going to transfer our local velocity to a global velocity. We'll do that by doing transform vector. And then we'll set a force mode to velocity change. Since the force mode is velocity change, we cannot set it directly to our current velocity, otherwise our player RigidBody will just accelerating infinitely. To achieve that, we need extra variable to calculate the difference between our current velocity and our RigidBody velocity. And then we're going to use the velocity difference instead. Finally, we're going to pass in our animator our current velocity so that we can animate correctly. Alright, that's it. The last step is to move our function to an update method. Since we're using RigidBody, we're using fixed update. Back to Unity editor. Be sure to drop in the player input component into our input manager. Our player can move now, but it doesn't have the organic and smooth transition between each animation states, and we'll do it now. The problem is that we're feeding our current velocity directly into our animator, so it's all 0 and 1, there's no middle point at all, and that's why the reason the blend tree is not working. In order to solve this, we're going to add an interpolation function. And finally, we need an extra constant to control our interpolation speed. We'll name the constant animation blend speed. Now, use the animation blend speed variable with the delta time constant to control the animation lerping time. Alright, that should be it. Now our player has really smooth animation transition thanks to the blend tree. Finally, it's time for our camera. Create an empty inside of our player amateur and name it camera root. And then expand the skeleton, hips, spine, chest, upper chest, neck, head, and then place our camera root inside of our left eye, and then place it properly. Around here is fine. Then, place our main camera inside of our player amateur. Back to coding, we need to add several more variables. First of all, we need to have access to both our camera root and camera. Let's proceed to create a method that controls the movement of the camera. Let's call it camera movements. Same, if the player doesn't have animator, this method will not run. Well, first, we have to get our mouse input from input manager. And then, we're gonna set a position of our camera to the camera root position. It's time to handle our vertical camera rotation. First, let's define another variable. This variable will control the rotation around the x-axis. And then let's go on to create two more variables that control the extent of the rotation around the x-axis. That's it. Finally, we need our mouse sensitivity. To calculate the vertical movements of our camera around x-axis, we need the product between our vertical mouse movements, our mouse sensitivity, and delta time. In this case, I use minus equals because it's the opposite of our direction. And then we need to clamp our x rotation to limit our vertical camera movement. And then finally, let's set the rotation to our camera. Let's also apply our horizontal camera movements by rotating our player. Going to rotate around the y-axis, and hence rotate around vector 3 dot up. As the last step, we need to place our camera movement method into late update method, because the late update method updates after fixed update. That's it. Back to Unity Editor. For our player controller, we need to fit in our camera root and our camera. And this is the result, the almost perfect full body FPS controller. Bonus clip. If you're annoyed by these visible moving cursors, here's how to remove them. In our input manager, we're gonna define a method called hideCursor. And then within the method, we're gonna set cursor.visible equals to false. And then cursor.lockState equals to cursor.lockMode.locked. And that's it. Now you cannot see the cursors anymore.